Okay, question 4 gets a little bit tricky, but you're really just using a formula here, right? You're looking for the average rate of change over an interval. So we're just going to use f of c minus f of 2 all over c minus 2. We're just using the formula. Now, f of c is going to be 3c squared plus 4c plus 1. F of 2 is going to become, well, f of 2 I know is going to be 3 times 4 plus, let's see, 4 times 2 is 8 plus 1, and I get 21. Okay, so minus 21 all over c minus 2. Now, work vertically so people can follow your work. So this simplifies into 3c squared plus 4c minus 20 over c minus 2. And then as long as you have this rational expression, let's see if we can factor this. 3c squared has got to be 3c and c. I have a c minus 2 in the denominator here. So let's see. I might say let's make that plus 10. Oh, and look what happens. So if I factor this into 3c plus 10, c minus 2, 10c minus 6c gives us the 4c, and those c minus 2's cancel out. So when I try to find the average rate of change over this interval, I can write it in a nice compact form, and you should too. It's just going to be 3c plus 10. So this is the AROC of this function over this interval that starts at 2 and goes to some unknown, right, end point. But then I'm going to use that for the next one, because then if they ask us for the average rate of change, so I'm going to say, so AROC here over 2 to something is going to be 3 times that something plus 10. Because then if they ask us for the average rate of change over this interval, 2 to 3, well, that's just going to be 3 times, notice c is 3 here. 3 times 3 plus 10, so that's going to give me 19. Over here, again, as long as I start with 2, this is my c value, so that's going to give me 3 times 2.5 plus 10, right? Again, I'm just using that formula. So that's 7.5 plus 10, so that becomes 17.5. This is going to be 3 times 2.1 plus 10, which is going to be 3 times 2.1 plus 10 is going to give me 16.3. This is going to be 3 times 2.01 plus 10. 3 times 2.01 plus 10 is 16.03. This is going to be 3 times 2.001 plus 10, so which is going to be 16.003. Now notice what's going on. I'm getting to have smaller and smaller and smaller and smaller intervals right focused on, or right immediately to the right of 2. So if we wanted to find the instantaneous rate of change at 2, so the rate of change not over an interval, but at 2, it's probably going to be pretty close to this. So I'm guessing 16.